So this is a brief introduction into what Arduino is. Arduino is made up of both hardware and software. So the hardware is actually the Arduino board, which looks something like this. This is a zoomed in view of the actual circuit board itself. And it's called a programmable circuit board, or PCB. And we'll often just refer to it as a microcontroller. We can actually program that microcontroller to control various electronics. We can use LEDs and servo motors, which is what you are going to use to actually turn the fingers, the phalanges on your hand eventually. And you've also got the software, the IDE, or Integrated Development Environment, which you guys will learn how to use to actually give instructions to the microcontroller. So we can use that to write. We can use the IDE to write and upload code to the microcontroller. And the code is probably the third component of what Arduino is. So you've got your hardware, you've got the software where you actually write the code, and then you have the code itself. Our goal is to use Arduino to code our bionic hand, or our prosthetic hand. I don't know if we should say bionic, our prosthetic hand, to complete tasks of your choosing. Now this one here looks pretty full on. It looks like a 3D printed hand here. And you can see the PCB in here. You've actually got the circuit board, and you've got some, it looks like we've got some power leads in here providing power to the circuit board. Ours won't look as technical as this, but it's a good idea, you know. It gives you a good idea of what ours will look like. Probably a scaled down version of that. So the microcontroller, it's the brains of the system, but it needs data to either sense. So it's going to take an input, it's going to sense something about the environment, or it might affect something. So that would be the output, such as output to a servo motor. An input could be a change in the current or voltage that it detects, and an output could be, in response to that, the blinking of an LED light or the moving of a servo. So this correlates to the read and write command that we use in coding. And don't worry too much about that now, but we will go into that at a later date. Here's an overview of the board itself. We're not going to go into too much detail right now in this lesson, but it's just here for your reference if you want to use this as sort of a map of where things are located on the board. So we won't go into too much detail here, and we'll keep moving along. All right, so let's have a look at a schematic diagram here of the board itself. Now you've got digital pins that run along the top of the board here, these green pins. They send and receive digital signals, and they're basically two states. It's either on or it's off. There's no in between, and that's what the digital pins will pick up. Analog pins are a little bit different. They'll receive some sort of analog value, which can be anything between 0 and 5 volts. So rather than just being on or off, two states, yes or no, this one down here can be a range of values between 0 and 5 volts. And this could be produced by some sort of input from a potentiometer, which is a type of resistor that's giving you some sort of input, possibly with the amount of pressure or temperature being detected. So rather than just yes or no, which is what the digital pins do, the analog pins will kind of pick up a range of values that it could use. So you've got the power pins, and they're used to power the board itself. And you've also got ground pins, which are really important. These two pins here that have already been circled, they complete the circuit and give the circuit a common reference point for some of the values that you'll actually input when you do your coding. So they're important to keep note of as well, those ground pins. And here we have some circuit basics. So for an Arduino to work, we need to create a circuit. And a circuit just consists of some sort of power source, some resistance, could be a light bulb, it could be a servo motor, it could be an LED, and obviously you need some sort of path for the electricity to flow through. So obviously copper wire would be a good example of an electrical path. You can have optional parts as well. So control could be, you've got a switch up here. And this should all be familiar to you guys, what a circuit is. and indicators. You could have LEDs here as well. So some sort of an indicator. But your basics have to basically have these three components. You've got to have some sort of power, some resistance, so you don't short circuit, and a path, obviously, for that current to flow through. So here are some basic circuit components. You guys should be pretty familiar with these. They look a little bit different, but we still have the same basic components here. We have cables to link things together. You've got resistors, provide a bit of resistance to the current. This one here, some people may remember in my class that Charlotte called me a dummy. I burnt my finger on one of these. They get pretty hot when they start resisting current. You've got a breadboard, something new you haven't seen. We're about to talk about in a second. These are what breadboards look like. We'll talk about that in a minute. Buttons, obviously, some way to switch on and off that particular circuit, and LEDs to light up in response to some sort of input. So they're your basic circuit components that we're going to work with. And the other one also is your servo motor. Again, we'll have a look at that in a second. So prototyping, this is what we're going to use this breadboard for. So you can see in the background this beigey coloured board here with lots of holes in it. And this image here, we seem to have a lot of components. So we've got some LEDs and some resistors hanging out of this particular board here. This is how you're going to test some of your circuits before you actually go ahead and do the final version. So we use the breadboard for prototyping or testing these circuits. The good news is we don't need to solder, so we avoid the need for soldering, which is permanently melting or welding some of these components together in a circuit. If you get something wrong and you put it in the wrong spot, it's as simple as pulling it out, putting it back in again, rather than that permanent welding of it in place. So things on the breadboard can be moved around and changed until we are satisfied. Like I just said, you're not happy where this LED is, or you put it in there by accident because you're talking to Brie, for instance, you can pull that straight out again and put it into the correct terminal where it should go. And you can see this LED, this guy here at the back, you can actually see it's in that hole there, and the other arm is in this hole here on the breadboard. Now, if you get that wrong, again, you can just lift that out and put it into the hole next to it, if it's not in the right spot. That's what we use a breadboard for. And the beauty is, again, you don't need to do any soldering. We avoid having to do that, which is a good thing. Here's what the breadboard circuits look like. We'll do this at a later date in more detail, so don't get too hung up on this. But let's just have a look at the anatomy of what these breadboard circuits are. So they have two different strips. You have a bus and terminal. The bus are the yellow, so that would be these strips here, and the cyan red are the terminal. So you've got in here, and you've got the red as well. And that's the three main circuits or types of circuits on the breadboard. Every point along the column for the terminal strip is connected. So you can actually see a line running down behind these terminals here. They're all connected down that row. Same with this one here in the red terminal. All of these are connected. So it's like a wire running all the way along that strip, and you can connect components into these different holes here. Each row of 5 in the middle, so the bus strip, the yellow, is connected as well. So these 5 here would be connected, and these 5 down here would be connected. These 5 would be connected. And again, it's like having a wire running behind those openings in the top of the breadboard. So each strip is essentially one wire, and these cables can connect separate strips. So you can attach something here, and you can join up to this little terminal over here, and then that may rejoin back to the bus strip there. So you can actually create these circuits by connecting the red, the blue, and the yellow strips. And you can place components all the way down the board and connect them up in various ways. And again, they're easy to change. All you're doing here is pulling out, pushing back in components, changing where they're actually located. So if you have a look back here on this one, you can actually see how this LED that I've already drawn in here connected there, well, that would look like being connected here and being connected here. All right, so whatever would be connected along these strips there and there would be connected to that LED as well. Same again, you've got your terminals along the side here. You can see the red are all connected, blue are all connected, and the bus strips in here, those 5 rows are all connected as well. So a potentiometer, it's essentially a voltage divider. And what that means is we can control electrical devices such as volume on audio equipment. Another thing you might be able to use a potentiometer for is a dimmer switch for a light. So it determines the brightness of the light rather than saying simply on and off. So remember, we have those digital inputs, which are it's either yes or no, it's on or off, it's 0 or 5 volts. Well, potentiometer is like an analog input where you can control to a finer detail what's going on with the output. And here we go, here's your servo motor. So this one here is incomplete. This one should actually have the big arm hanging off the top here, like so, that you'll eventually attach your wires to, that will move your phalanges. That's a pretty terrible drawing, but anyway, I think most of my class you've seen what these look like with their arms connected. They're used for circular movements, and they will move by a number of degrees. Using your Arduino, you can tell the servo motor which degrees you want it to move via coding, which is exactly what we're going to learn how to do. A sketch. So this is what we call the code. So programs written for Arduino are called sketches, or the code written. So this over here, we're looking at a sketch. It's a series of instructions. Compiling the sketch will check the code so that it makes sense, and we can click verify to do this. So at the bottom here, when it's done loading here, we can just verify via different colors of text, for instance, that we've actually got the code set up and it's going to work properly. So it kind of checks it for you before you go ahead and actually give it to the microcontroller, which is kind of handy. Again, why Arduino is so handy to use. It does this kind of checking for you, so you don't have to be a computer scientist or an electrical engineer to get this stuff to work. We can upload the sketch and it sends the code basically to the microcontroller. And whatever our outputs happen to be, the microcontroller, depending on what our sketch is, will start providing some sort of output to the servo motor. So that's what a sketch is. It's basically the code or instructions for our microcontroller.